I'd like to welcome you all here today to the Transport and Mobility Forum, where we're here to talk about the end-of-life vehicles and battery circularity, and probably talk a little bit wider than that as part of the journey that we're going to go through today. So this is the final session in the Transport and Mobility Forum, and we'll be delving into the intersection of electric vehicle adoption and sustainable resource management. The rapid uptakes of EV, as we all know, is crucial for the decarbonisation of transport and meeting our climate goals. Yet this shift poses challenges in material demand and supply chain risks. So let's discover how discarded EVs and their EV batteries present new business opportunities and second life applications and recycling initiatives. So we're here to explore the strategies and navigate these complexities and advance circularity in the automotive and battery industries. And I suppose I should probably start by actually introducing myself, a little bit backwards, but there you go. So my name is Claire Spooner. I am Director of Mobility at Innovate UK. We have a fantastic panel to talk about these topics today. We're going to start with a journey, basically, where we are going to talk through what are the reasons that we actually need to care about decarbonising transport, what are the targets we're trying to hit. We're then going to look at the manufacturing section and what are the manufacturing challenges behind creating these vehicles moving forward. We're then going to really touch on recycling and then also wrap that up into supply chains activities. So I'm going to hand us over to Siobhan to introduce herself as my first speaker on my panel today.
Hello everyone, so I am Siobhan Campbell. I am a technical director in WSP, a large engineering consultancy, and currently working on a range of things that are really close to my heart, such as innovation management. How do you get from that point of a bright idea into business as usual, which is the real challenge. It's not just about the ideas, it's about operationalising that. And very, very interested in the socio-technical aspects of everything as well. So how do you bring people and technology together? One of the reasons I've been invited onto this panel, though, is because of my role, my previous role as Deputy Chief Scientific Advisor at the Department for Transport, where I was responsible for really the oversight of R&D across the whole of the Department for Transport, and ensuring that evidence and R&D was embedded across the piece and into all of DFT's activities. Particularly interested in things such as innovation, emerging technologies, and that collaboration and engagement. As you've heard through a lot of these panels that I listened to today, it's not about individually what we're doing, but collectively how do we get there.
So Siobhan, I wonder if you wanted to just talk us through the landscape and tell us about those net zero targets for 2050.
Love to, Claire. So it's not new to people. You're not sitting in this room because you don't know or care about it, but just to recap, Transport's particularly naughty. It's the largest emitting sector. 26% of all emissions, or greenhouse gas emissions, are transport related. Of that, 91% are from road vehicles. I mean, that's huge. Biggest contributors, cars and taxis. HGVs are 20% of domestic transport emissions, and vans are 17%. Vans are also going up like this, and so there's a real naughty issues here. And I think the other really core thing is that in 2019, transport emissions were 4% higher than 2013, and they were only 3% lower than they were in 1990. We've flatlined on transport emissions, and it's a really, really big problem. It's not necessarily to do with efficiency of batteries or efficiency of technology. It's a lot to do with the number of vehicles and the vehicle miles, but there's a really big problem and it's really intractable.
That's a really excellent summary. And I suppose if we look at the role of batteries and electric vehicles, how do you see they play into that global effort to decarbonise transportation?
So I think core here is that so I said 91% of these emissions are cars and are road vehicles. There's loads of really, really difficult things to decarbonise, and we actually know the route forward. We know the route forward for batteries. Batteries is a fundamental way to get there. However, they're quite energy intensive themselves, and so it's really important that we, as well as getting net zero technologies, we reduce the carbon involved in these technologies as well.
So moving on to Jacqui. Would you like to introduce yourself, Jacqui?
Hi everyone, I'm Jacqui Murray. I'm the Chief Operating Officer of the National Manufacturing Institute of Scotland. I did a stint as managing director of the recycling joint venture between British Volt and Glencore in batteries. So I spent a good time looking at the business model for having a gigafactory and for battery recycling. I'm a metallurgist by background. I'm ex-steel, I'm ex-environmental regulator, but most people know me from being deputy director of the Faraday Battery Challenge.
Excellent. And I suppose really touching on your expertise at Ennis, why is it crucial for battery manufacturing to be kind of centred in the UK?
So I think we sort of missed the point sometimes with the net zero. You can decarbonise the whole transport system here without making anything. You can import the vehicles, you can import the cars. But the UK's core competence really in vehicles is around making things move, making things go, propulsion systems. So when I first started in batteries, the UK made about 1.7 million cars. That was in 2017, but they made 2.5 million engines. So what you've actually then got is you've got a drop in those numbers. So today we're sort of seeing sort of around 2 million. Chris was reminding me not to go for the exact number. Around 2 million new registrations in the UK. So we have vehicles coming on the road here, and we've made about 1 million in the UK. So we always import and export. There's always going to be that flow. But what you're not really doing is profiting here from those vehicles and moving that. And then you add in the fact that they move, right? So actually it's very easy for us to lose even the materials that are embodied in them at their end of life. So if we're not manufacturing them, we're not then dismantling them, we're not taking them through the circular route.
And linked to that, what are those potential economic benefits and job opportunities associated with building a robust battery and electric vehicle sector in the UK?
Yeah, I think we forget that automotive is one of the most productive sectors. I don't know the exact numbers today, but it's a huge proportion of jobs in our manufacturing sectors are in the UK. Whether it's in Scotland, Northern Ireland, England or Wales, you know, it's a really significant contributor, you can tell it's 4 o'clock, session, back to the UK economy. And I think we're, you know, we'd really lose something, you know, when you look at, even if you transfer it to motorsport, right? So we all know a lot of motorsport is based in the UK, a lot of the teams are based here. It's that ability to make things go by integrating all those engineering systems, all the way from manufacturing the materials to the end of life, and we've got to really not lose that knowledge.
Yeah, and they're high quality jobs as well.
Yeah, very high quality, well paid, and I think it's also, you know, you forget how it's not just the jobs on plant, it's the supply chain in as well, and you know, we can risk building gigafactories that actually we've not got very much of the supply chain, so we've got to be pretty savvy here.
Okay, so moving on to Helen. Helen, let me see. Would you like to introduce yourself, and then I'll ask you a first question.
So I'm Helen Waters, and I head up our electric vehicle battery recycling program for EMR. EMR are one of the biggest recyclers of metal in the world. We do about 10,000 tonnes of metal every single year. You could argue we don't need to do this yet in terms of EV batteries, but what we recognise is there's such a journey to travel in terms of everything that needs to be done and the processes and the actual kind of all the chemistry of how you process and treat this material. I always say this, but you know, it took 40 years to get us to a point where we actively process an ICE car, and we've been given 5 to 10 years to then translate that into EV batteries, which are completely different. You know, to put it into perspective, you can't take an ICE car and put it straight into a shredder. If you do that, there'll be lots of explosions and fireworks and all nasty things. You've got to be able to do that very differently. So we've come in this very, very early in the market, and I was brought in really from my experience of in startups. I had 10 years at Copart, who are a big vehicle remarketer, and really trying to understand how those things need to be put in place and what we should be doing now.
So kind of touching on that, you mentioned some of the challenges with recycling batteries and electric vehicles, those end-of-life activities. So how do they impact kind of on the UK's circular economy efforts? What are the challenges that you see?
I think to start with, today's problem is that EV batteries don't have a value. In fact, they have the opposite. They are a cost to be able to recycle. That will change as volumes grow and people come online with their recycling processes. I think we are late to the party in lots of respects over the design of those vehicles. So we've done lots of work in the last 2 or 3 years in terms of engaging with OEMs, and battery makers and anyone we can kind of engage with to get us into that early stage process. But we've got to be able to recycle what's on the market today. We've also got to then turn that into something that can go back into cars as well and keep it, like you say, within the circular economy, trying to keep it into the UK and at very least into Europe. So collaboration is key to making this work.
And there are a lot of new regulations and standards and rules coming in at quite a fast pace to get us to kind of 2030, 2027, I think some of the EU rules coming in.
2027, the first ones. Yeah, and I think, there's a lot of responsibilities that are kind of being used for the recycler to be able to be responsible for. And we push back on that a little bit because we can only recycle what somebody's made, and if it's recyclable material, happy days.
Yeah.
But we need to work with those individuals to be able to create that circular economy in the right way.
Yeah, it's very important not just to have black mass being the end product.
And black mass, what is it? It's only as good as the material that you put in. It's this lovely, come and see me afterwards, I'll bore you rigid about black mass, but what we're doing as my background actually isn't as a chemist, my background is as a social scientist, but even I can see that black mass needs somebody like us to come in and be able to create that separation process for lots of different things. For example, at the moment, lots of batteries have graphite in them. You can't get the graphite out. We need to be able to do those things, and that's why it's important to start the processes now.
Excellent. Chris, moving on to you. Would you like to introduce yourself?
Yeah, I'm Chris Jones, Strategic Trends Manager at the APC. So the APC essentially funds automotive industry projects that are trying to move the automotive industry towards zero emission and net zero manufacturing. My background is in material science, so I come at this with a very material science point of view, and I get very excited about the role of materials in the transition to net zero. So when it comes to batteries, the thing that I really kind of geek out on is the material supply chains and the decarbonisation of those supply chains, and also recycling. I think something that I've learned, because I was and am fixated on those materials, is that we do focus on recycling. Recycling's great, but there is that question of extending the life of batteries and being able to reuse them as well.
So, looking at the electric vehicle ownership, how's that going to impact the automotive industry's approach to end-of-life vehicles?
So I really don't envy Helen and companies like EMR, because, as mentioned, we import a lot of vehicles, and there's a lot of variety in the vehicles that we import. So if you looked at the UK and you were to say we have 5-6 manufacturers and it was that simple, that would be okay. But that's not what we have in the UK that needs to be recycled. And the batteries that are in the vehicles, there are different cell designs, physical designs of the cells, different physical designs of the packs. How they're integrated into the vehicle is different. And the chemistry is different, and none of this is getting simpler. It continues to evolve. So there'll be vehicles coming into the market this year with new electrolytes, semi-solid electrolytes, in the future, solid state, and you might think that's a future problem and say, well, hang on, we're not going to have to deal with that for 10 years. But if one of those vehicles has a crash next week, Helen's got to deal with it. Yeah. and then when you're getting new designs, new chemistries in ones and twos, how on earth do you make money out of that? And Helen's already touched on that you can't.
Yeah, it's quite a massive challenge, and I suppose one of those challenges is how do industry and policymakers collaborate to really foster the innovation and the consistency in the supply of materials. I wonder if you had any thoughts.
Yeah, so one of the things, just to give a bit of scene setting on this, when we talk about recycling, and we talk about recycling an internal combustion engine vehicle, I think we can all fairly easily imagine a lump of metal and melting that and making something new. I know it's not quite that simple, right? But we can imagine that, and it's physical and it feels sensible. Yeah. When you look at a battery pack, if you look between the sort of wheels of a vehicle, modern EVs on the market, coming on the market now, that battery pack sits between those wheels. It's a massive lump. It weighs more than half a ton. EU battery regulations say you've got to extract the lithium, the nickel, the cobalt from that. The lithium is 6 kilos of that half a ton. So you've got to try and imagine taking that half a ton lump and extracting, with the required efficiency, 6 kilos of material. that then needs to be processed to go back into the supply chain.
Yeah.
And it's an incredibly complex problem, and it gets worse when you start saying, with different chemistries, I need a different process.
So, Helen, I think you want to jump in here.
And I think I'd add to that is then you've got all the other things that are in that battery that make it very volatile.
Yeah.
So you've got to protect people through all of that. And at the moment, it's a very manual process to disassemble that battery. Now, that will change. As time goes on, shredders will get bigger. There are some that can shred whole packs at the moment. They've still got a lot of contamination in there. That's not particularly where it should be right now. But there will be a time and a point where you can possibly do that in whole packs. But until we get to that point, there's actually a big journey to go, because I've got to be in a position where I can protect my people when they take the lift the lid off that, to know that they're not going to have HF gas escape, that they're not going to have anything else that's going to happen to them, and that it's not going to set fire. So we've really got a massive journey to have, and the collaboration that we already do together, the collaboration we do with the OEMs, is so crucial to making that work.
And Jacqui, I think you wanted to jump in.
Yeah, so I'm going to come in from an OEM perspective as well, because just so you get the layered complexity. I also don't want anyone to know what's in my battery. I don't want to let them know the configuration. I have IP, it's my differentiator for my vehicle. So therefore, EMR,
Yeah.
I'm going to want to keep it secret, right? And then the other bit that I want as an OEM, I've sat with a big European OEM and listened to them basically demanding a gigafactory that will take those materials, turn them into batteries, I can put it into my car, and it can bring those same materials, those same 6 kilos of lithium, and put it back round into and drive that circularity, which is a lovely notion. But the complexity of doing that, from a logistics point of view, let alone a technical point of view, is challenging.
But then what will happen is they'll change the chemistry of those batteries. And so then you have to start all over again, don't you? So I think it sounds like it's all doom and gloom, and it's really not. It's actually really exciting, and I pinch myself and feel very happy that I'm in the position that I am in to be able to sort this problem out. Because, if we'd have been left this for another 10 or 15 years, which is when the ELVs will really start to come in, then we'd all be scratching our heads and saying, uh-oh, look at this big problem. What we've got to be able to do is work as an industry to bring all of the different legislation together, because it's not just about the battery regulations. You've also got the changes in ELV directive, so end-of-life vehicle directive. You've also got producer responsibilities. All of a sudden, OEMs are listening, which is great news, but we've got to be able to balance that, spend the right amount of time on the right things to end up with the right result, which is make the vehicles with the right materials. We can then recycle it in the most effective way. And there'll be lots of different divergences off that recycling process. Recycling is talked about as this one journey, and it's actually not. It's probably 5 or 6, 7, 8, 9, 10 pieces of a journey that starts with, we take the vehicle in at end of life, we take the battery out, and already that part's already separated, because you've got the hulk and the metal that go off one way, and you've got the batteries that then come to somebody like us. And then you've got disassembly and getting it ready for shredding. Then you've got the shredding part, and even that, we've then got to separate all the different chemistries off and make it all into the right pots. And then you've got different processes that sit right at the end to then put that material back and do your 6% lithium.
Yeah, and with disassembly, obviously the way that the vehicle is constructed in the first place, with Tesla putting its batteries in its chassis, that adds another layer of complexity to the challenge.
But the good thing is, the more you see of those, the better you get at it. Already 18 months into our Recavas project, which is the Innovate UK funded and APC, already we've been able to see hundreds of different battery types, which we wouldn't have seen up until this point. So, that you keep learning.
And sorry, just one point. I think the other thing, the kind of fundamental thing is that ultimately there will be a recyclable option, where if you're talking about hydrocarbons and burning them, you burn them, they're gone. And so there's a prize here that we need to all be searching for, because that's where the benefit comes from.
And as you do that, you've got to keep questioning that on every process that's coming through, because when you do something to one part of the recycling, you may create something that then goes to that. So at every stage, you've got to question it.
Yeah. So I'm going to ask another question of the panel in a second, but you are allowed to submit ideas. I think there's a QR code. If you scan the QR code, then your questions will magically appear on my iPad, and I will be able to ask them on further than that. And naturally, in the way of these things, I've completely forgotten the very pertinent question that I had in my head for you all. It was the best question you have ever heard. It's just sadly gone. I think, yes, it's linking into this kind of policy directives. There's a lot of activity going on and how to get those policies right for the new manufacturers coming on stream. But we do have a first question here. So it's to Chris. This is one who's been highlighted to. And it's, are batteries the way we know today? What will be used from a future trend point of view with those batteries?
So what was the question again?
It's basically what are the future trends in batteries, and again, how does that, I suppose, link into those challenges that Helen will be facing at ERM?
Yeah, so, well, I mentioned battery chemistry. So most batteries right now are a certain chemistry. They're nickel, manganese, and cobalt. And this, again, points to the regulation, which says you've got to recycle those materials and get those materials back into the supply chain. There is also a lithium iron phosphate chemistry, which is growing in popularity, is extremely popular in China. Many of you will have heard that there are Chinese vehicles coming to these shores. They will be lithium iron phosphate, which means you've now got this other chemistry you have to deal with. The problem from the regulatory point of view is their requirement doesn't seem to have quite taken into account this changing mix. So LFP is not, lithium iron phosphate, LFP, sorry, it is not so economically viable to recycle because the only valuable thing you get out is lithium. And as I said, it's 6 kilos in that enormous lump of stuff. So it's even more difficult to make money than it is from something with cobalt and nickel. And then we've got completely new designs that are being integrated into the vehicle, which creates another challenge.
So I'm going to open this one up to Jacqui. So can we also link, and this is from Dan Cook, can we also link recycling? Naturally, it's just disappeared, which is terrible. Can we also link recycling back to original kind of commercial sector batteries as well? And so the battery is being recycled and then it's used by a commercial activity, and to start with, it's a commercial battery for, say, static storage, and then it's recycled into...
Yeah, absolutely. So lots of thought processes going into all of this. So if I take it to pre-EMR, if I'm a OEM, and I know Nissan were looking at this in particular, I'm currently doing research on how I can take end-of-life vehicle batteries that I'm responsible for, as we've sort of accepted a producer responsibility on them, and how can I dismantle them, do something with them to increase the sustainability. Yeah. So that could be anything from, domestic batteries for housing to store your energy off your solar panels, all the way through to big grid scale storage facilities. There's lots of challenges in all of this at every stage. You'd like to think the first step would be, can I recover the module or the battery that's not working in the vehicle and keep the vehicle on the road? And that in itself gives the car company a problem because their model is that they hit an end of life. And actually batteries are lasting longer than that 8-year, 9-year sweet spot that car companies would like you to change your vehicle, right? But we need to move that forward because that's the biggest impact on sustainability, the longer that battery stays in first life. Second life, then it's like, well, who's responsible if I take this battery out of a vehicle and someone's crashed it, it's got something we didn't know about wrong with it, who's liable if there's an explosion or there's an issue with it? Yeah. It's a real challenge, and but we're starting to see it. If you were here earlier, I was listening to Chris's colleague Philippa talking about the digitalization and the diagnostic tools that are coming that allow you much higher confidence levels in what that end-of-life, first-life battery looks like. And I think the other piece of the puzzle that we forget is the insurance companies. Yeah. They're very worried about actually how you can do all this. So Second Life has still got challenges on liability and insurance and things like that. But I think there's a real drive towards it. The more we know, the more we understand life cycle assessment of those, we start to know where the right answers are, and we can drive much more towards that.
I think just adding to that as well, that there will be a market for it. I really think there will. Yeah. But ultimately, it's got to have some volume to it because the startups that are coming into the market at the moment want all of the same types of batteries to make it work, which I get because you're trying to build something and they're all different, as we've already discussed. So it needs the volume to be able to create that market too, doesn't it?
For me, there's some really interesting space here around the equipment manufacturers, the people people that make the car manufacturing equipment, for example. You know, those robots we used to see on telly when we were young.
I want to say Tomorrow's World, but that feels not quite right.
So actually, if your skill set is equipment that manufacture cars, actually having the same people looking at how you dismantle multiple different forms and chemistries and everything else, and that sorting. So you can see a gap. It is what Tier 1 automotive and the automotive industry have been doing for 120 years. So it is a problem that you expect to get solved, but it's going to get solved by some big players because it's going to take some serious initial investment up front.
So, touching on to policy design, Siobhan, because you're obviously very familiar with that landscape, having worked in the Department of Transport. Someone here has suggested, how about we do a buyback scheme? And as part of that buyback scheme, it would be compulsory for manufacturers, distributors of EVs in the UK to buy back the product at the end of it. From your experience, does that kind of buyback scheme, does that work? Or where would you take the policy direction?
I think the challenge here is doing something unilaterally in the UK is really difficult, and I think that's where international cooperation is essential, because things we do here can drastically backfire if you don't think through this properly. We are a small player in the world, much as we're a substantial player, we are a small player. This is a much bigger market, and also we're talking about here about kind of car batteries, but actually the market is going to be much bigger than that. And again, these are all international things. Cars travel across borders, ships, aviation travel across borders. So I think it's really important to explore all these ideas, but it's really important to engage and involve yourself in these international negotiations, understand what's happening at a kind of European level or broader, and be a player in that in that space, so we can help shape things, but we can't. I think it's really dangerous to take unilateral action.
Yeah, Jacqui.
I'm just going to also look at it through an OEM lens. You know, for me, if I'm, I don't know, BMW, Nissan, whoever it might be, if one of those batteries ends up causing an explosion or damage because it's not being recycled, it's my brand on it. So actually, I'm selling this new green product to everybody here. I want you guys to buy an EV. If at the end of its life, it's causing a problem environmentally. And I think, you know, when you look at Apple and iPads, you remember the sort of some of the press around, negative press around it.
The earbuds that can't be recycled.
Yeah, or the cobalt, and you know, people talk about cobalt in batteries, right? And DRC and the Democratic Republic of Congo, much worse in your mobile phones, by the way, than your electric vehicle battery or in your iPad. So really interesting to see how that also shapes company policy as well as, you know, government policy. You regulate where you need to, but on the whole, what you're trying to do is move companies forward, and they have taken that.
Yeah.
You know, I know they're bedding in that risk. So end-of-life vehicles, they expect to have to pay for it at the moment, but they know there's value in them because of the materials, like Chris was saying.
So, Chris, there's a question coming here, which is about EV battery business. If a car manufacturer keeps it as a closed loop, so how do we make that second life battery business growth and be used more broadly? How would you approach that with your work?
Well, I think, in many ways, an OEM having a closed loop themselves actually makes a lot of sense, right? Because they can control the chemistry, they can control the design, they can actually have a far more efficient recycling loop. So if an OEM says, we are going to have our own gigafactory and we are going to recycle for our gigafactory, that actually makes a lot of sense for them as a business model.
Yeah.
And I think we may well see a lot more of that, where there's actually a greater integration of that supply chain. I think the model where you have black mass that then goes somewhere else and they're dealing with lots of different types is harder to make efficient and therefore make money out of. It's also not directly linked to a customer. So the customer of that material is a cathode manufacturer or an anode manufacturer. So if you haven't got someone to sell it onto, how do you make money out of it? Bringing it to the UK, we have gigafactories here. We're building more gigafactories. We do not have that part of the supply chain. So right now, that material has to go somewhere else because there's no one to buy it, even though the gigafactories are there. So I think we'll start seeing more and more of that integration.
And this touches on a question by Claire Miller, which I always welcome a question by another Claire. It's a thing. So how soon will it be economically attractive to recycle all batteries and buy new ones for all applications? So no second life. When does that kind of loop start to materialise? So we'll go to Helen and then Jacqui.
I think it's when the volume starts to come in. So and that's always the same thing, isn't it? The other thing is I think it's when the other parts of the recycling chain start to come online. So at the moment there's limited shredding capacity in Europe, for example, and there's virtually zero in terms of refining, which is what you're referring to, isn't it?
Yeah.
The refining bit is the touch point at the moment because it's so expensive. So that's why you need different collaborations to bring down that final refining cost. You know, at the moment it's quoted for anywhere between $600 to $800 million in terms of setting one of those centres up. And if you think about how they're going to guarantee that comes back in if they've not got a link to the gigafactories like you're suggesting, they're the reasons that we haven't seen those come online at the moment. Having more gigafactories in the UK is a really good thing because it will attract them because the volumes will be there. Making sure we keep those end-of-life vehicles in the UK and we recycle them in the way that we're doing will also make sure that there's volume there. So I think you will start to see some better pricing coming in as those shredding opportunities come in place, because at the moment you're sending it to 2 or 3 different versions before you're getting even. And some of those are in the UK, some of those are not, but none of them can do it at volume yet. So I think once you start seeing that comes online, probably from about August to the end of this year, some of those things will start to ease. But positive value, I think, is some time off yet, more like 3 to 5 years.
Jacqui, do you want to come in?
Yeah, so having a materials background like Chris, economy of scale is massive, which is what you're saying, right? And that's also in the logistics end of things, which the waste industry and EMR, people at EMR do brilliantly. I think there's a slightly missing piece of the puzzle that's waiting in the wings, that is almost invisible to most people, right? So if you look at Northvolt, they have a battery joint venture between Norsk Hydro, a massive aluminium company, and a recycler, right? And then you're starting to see volumes because they're taking gigafactory waste streams as well as batteries from specific car companies, and they're making a very good business out of it. Norsk Hydro can take all the aluminium they can make on it and take it at different levels and different cleanlinesses and at different points of the growth. So as you scale up, they can take pretty crappy aluminium and put it into more primary sort of smelting applications. Or they can start to feed in the higher value stuff right the way through. They start to be able to make money. It's why I went to the Glencore. Glencore's a good example, right? They have copper smelters, cobalt smelters. You know, actually they can start to play games with that volume scale piece. And I think some of those big materials companies, they're out there, they're watching when they start to invest because it's the scale. You're talking about, you know, you need companies that are used to spending, you know, billions of pounds on infrastructure to do some of this stuff, and working with then the waste industries, as you do now, right? You work with Tata and others. These companies are of that scale, but it's a volume game.
It is totally a volume game.
Can I,
We'll come to Chris, and then I've got another question for Siobhan.
just to add that understanding when that volume is actually going to happen is really hard, and JLR have announced and shown off that they're putting I-paste batteries into secondary storage because they can sell it.
Yeah.
They can make money out of it, whereas recycling right now they don't get anything back effectively. Renault have also said that they are going to take batteries from end-of-life vehicles and refurbish them for repair. So if a vehicle comes in for repair, they have a battery ready to go as a cheaper version to stick in. All of those sorts of things where there is value in the battery and some repair allows them to make some money out of it is pushing that scale for recycling further away. And we don't yet know where it's going to land.
But actually it's the right thing to happen because, you know, and I sit on a recycler, I am a recycler, but I only want the material when it is at the end of its life. And I think that's the thing here is we've got a big journey to go on how to recycle that material, but as long as you know how to do it and you can get the most out of it, when that volume comes is that's okay if it's a little bit longer.
So,
and the other thing I'd say is, well, it's not just, you know, we're talking automotive today, but actually there's a load of other batteries that do exactly the same thing that are not automotive. So we've got to make sure that we're kind of harnessing everything, and we're not just, you know, the biggest problem is automotive batteries, but lots of other things out there as well.
And I think that touches on where I'd like to bring Siobhan into from that policy perspective again. So we have had the Advanced Manufacturing Plan released last year, and we have the UK Battery Strategy released, which covers that design, build, sustain element, those three very crucial things. That systems approach, how important do you think that is to the piece?
So it's absolutely critical, and I mean, I think systems approach is critical to pretty much any problem you want to look at. But I think for this, it's particularly critical, and I think we talked about it earlier, Helen. The kind of the risk of adverse consequences of doing something at one small part of the system and then something flying out the other side, especially when things are evolving so fast, that it's absolutely crucial. And it's really encouraging that government are much more in that kind of system space and looking at things as a whole. But it's tricky, and it makes everything more complicated. It makes the policy messages more complicated. You can't just say, well, this is the problem, this is the answer. And so I think it does create more communications issues, but I think it's absolutely the right way to go about things.
And following on from that, this is quite a controversial one, I quite like it, it's from Claire Miller again. Do we need to have more proactive legislation that EVs stay in the UK once they arrive, or even made here, to provide that mining feedstock of the future? What do you think, Chris?
I think, as Siobhan said earlier, it's an international market. I think that's incredibly difficult to enforce. So if we're buying vehicles from BMW and we are saying that the OEM has to be responsible, surely they have to go back to BMW and they get to choose where they go.
Okay.
I'm not entirely sure that we can necessarily close the border on vehicles. But
I said it was controversial,
yeah,
Jacqui.
yeah.
Just to be even more controversial, add to it, I think you might be surprised how many EV batteries, end-of-life EV batteries, are stored on OEM sites at the moment.
That is quite controversial. Yes.
And it's actually all batteries. I mean, hands up here who doesn't have an old mobile phone in a drawer somewhere at home.
I totally
Because you don't know quite what to do with it.
Yeah.
It's the same for those OEM producers. So yeah, they're out there in volume, waiting for people to work out what happens next.
And to the whole panel here, do you think we would ever regulate which battery chemistries can be used in order to support a thriving recycling activity later on? Who wants to jump in?
I'll go on that.
Yeah.
It's a differentiated product,
Yeah.
right? So, we all get into a car, and it might be a cheap car or it might be a really expensive car, but we get into it and we do assess it on how it drives and how it feels to drive. Whether that's because you're obsessed with, miles per kilowatt hour or whatever. It is part of that big differentiation of that product. So I think you'll struggle to regulate for car companies to tell them what chemistries you are, but you may well ban things. So, for example, NMP, one of the solvents used in most lithium-ion batteries, is on the to ban list because it causes defects and birth defects if women come into contact with it. So you can see the more batteries we make in Europe, the more sensitive, the more exposure you're giving people. So I think they'll stick to that way of regulating and also an eco-design approach. So, when you buy your washing machines, you've got a label on it telling you what the energy efficiency is. I'd expect to see the same on batteries. The reason they do that is that as consumers we can make better decisions, but also you don't see very many poor performance anymore because they're blocked from trading if they're low grade.
I don't know, you should see my washing machine, that is poor performance. Siobhan, I know you wanted to jump in there.
So I completely agree with all of that, and I think the other thing is you can't aspire to be a science superpower and invest in innovation and say that you're really wanting, especially in such a rapidly evolving sector, and then we're locking things down here. And so you need to allow that flexibility, and you need that kind of outcome focus. This is what we want you to do. This is kind of where we want you to drive the industry, but we can't say you're stopping here.
Agreed. Helen.
I think as well it'll self-regulate in the end because you'll have the OEMs that will be in, like you say, the certain bandings of vehicles and making and all those sorts of things. You could argue LFP has already started to regulate the industry because there's lots of kind of, because they're not the most expensive batteries, but they give a good range, they're starting to appear more and more. And I just think it will regulate itself eventually. We're just in this massive transition at the moment.
So I guess government will always regulate where it feels it needs to. You see that with the car emissions. The reason why car companies have made this huge investment to EVs is because there's been a tailpipe CO2 emission target. So they'll do that, but to regulate on chemistry would be unusual unless there's something particularly damaging around it.
So we're in the final session of the Transport and Mobility Forum. There's a final few minutes before people are allowed to escape, pack up their stands and run away. We are asking everyone in the audience to think about this, but I'm going to challenge the panel as well. It doesn't mean I'm going to answer it, but I will challenge the panel. So basically, if you could make a specific request or a call to action today, while attending Innovation Zero, what would it be? So I suppose you have a summary thought about that you would like, a key message you'd like to leave today, and then what would your call to action be? What would you want to see changed moving forward? And Siobhan, you're at the end of the line. Sorry, so you're the first person I come to.
So this comes, and maybe I'm stealing your thunder, Helen, just as a social scientist on this panel, I think it has to be around the people. That it's really easy to get really obsessed about the technology and the chemistry and everything about it, and this is going to be used by people, it's going to be used by consumers, it's going to be used by businesses, but people in businesses, and we need to bring them on the journey. And I think there's some really worrying signs about how we're not doing that, and I think especially people can understand things and they can buy into things and they get passionate about it. You can see from research that they do understand and get and are concerned about climate change. Bring them on the journey with us.
Jacqui, that's to you now.
So I'll go down the people route, but a slightly different one. You know, I think we really, really want the skills needed to make a difference in this space. So my call to action would be, you know, to look at actually for recycling, for example, or whatever part of the industry you're in, what's those transformational skills needed, and how can you encourage those skills to come forward? You know, I'll give an example: dismantling a car battery that's a high voltage live system. You need probably a master's in electrical engineering to get the high voltage live certification. To do that, nobody who's got that is going to stand in a shed. Sorry, no offence, but a cold unit. Dismantling batteries.
New place, though. It doesn't look like that.
No, true. But would you want to? I'm sure you're not employing
you're right.
like 40 very highly qualified electrical engineers to do some of that work. So we need skills in robotics and all those symbiotic sort of areas as well. So yeah, think about the skills needed for the energy transition. Okay. They're vast.
Yeah, they are. Helen, what would you do? What's your call to action?
So my social action is slightly different. It just in terms of collaboration, really. It is collaboration and more of what we see already. And, you know, the fact that we have the government funding and we've got some of the APC's money and all that sort of stuff to go with is brilliant. Yes, we need to work that out, and we need to make sure that we're making businesses that are sustainable and can live on by themselves without the money. But ultimately, if we're starting right from the beginning, which is tell me about the design you're thinking of and tell me about what you're going to put in that. And that's not just about batteries either. You know, if my colleague from our plastics division was here, he'd be saying exactly the same. You know, he can provide a list of polymers that absolutely could be recycled very easily, and he can provide a list that is actually really difficult. So that collaboration right from the beginning is my call to action.
And Chris, what's your call to action?
I'd like to see more talk about repairability and more thought about optimising the life cycle of a battery. I see in the press there's a lot of talk about, are we doing enough with recycling? What's happening to black mass? Look at this EU regulation. Why aren't we copying it? Maybe it's the wrong thing to copy because it is very focused on driving one particular behaviour. And what if that's the wrong behaviour? And we need a better understanding of the battery life cycle to make better choices.
And I suppose I should share my call to action. And it really is, it's about thinking differently, and it really touches on that skills piece that Jacqui was mentioning. And I love this story. Unfortunately, it's anecdotal, so we never know quite how true it is. But I was talking to some colleagues at the UK Battery Industrialisation Centre. And this is a research and development gigafactory that we have in the UK where you can try out your different chemistries, and it's just a fantastic facility. Anecdotally, they have said that actually hairdressers make incredibly good battery manufacturers and battery technicians. And the reason for that is because they've mixed chemicals their entire lives. And you suddenly start thinking, well, hang on, are we looking for where the skills are in the right places? We have really high quality jobs, and actually we can maybe find different pools of people who can fill them. Bakers, again, are meant to be incredibly good at mixing the chemicals that we have. And so thinking that a little bit differently, maybe not having so many preconceptions. And I know literally everyone on this panel is doing an absolutely sterling job of helping us understand this ecosystem. And I'd like to get you all to thank them for their contributions today.